Most indie beginners movie player, but many don't actually know what's happening behind the scenes. The character moves, the game runs, everyone is happy. But what about the actual code? Completely mysterious. So let's fix that today. Right now I am in the Unity scene. When I move this player object, look at the transform component. See the position values changing. If the X value changes, the player moves left or right. If the Z value changes, the player moves forward or backward. And the Y axis is usually used for height, like jumping. So in simple terms, moving a player in Unity just means changing its position values. But imagine controlling your player from the inspector like this during gameplay. Press play, move X, move Z, stop, change again. If you are doing like that, congratulations, you have just invented the world's slowest game controller. So instead of this, we'll add the keyboard to control the player. And Unity already helps us with the something called Input.Axis. If I open the input settings, you will see horizontal and vertical axis. Horizontal represents A and D, or the left and right arrow keys. Vertical represents W and S, or the up and down arrow keys. Basically, Unity already understands what keys we want to use, which is nice. Because typing every key manually would make the script about 300 lines long. Now let's write the script. First, I will create a new C# script called player moment and open it. First, I am declaring the speed to say how much speed the player need to move. And after declaring the speed, inside the update function, we will start reading the input. First, we store the horizontal input. For that, I will write float x equal to Input.GetAxis horizontal. Now you might ask, why am I using float and not int? Because Unity does not just give values like -1, 0 or 1. When you press a key, the value smoothly increases. It might go from 0 to 1 from decimal values, and only a float can store decimal values. If we used an int, Unity would basically say decimals. Never heard of them. Now let's read the vertical input. For that, I will write float z equal to Input.GetAxis vertical. Now we know we are taking only the inputs but not moving anything. Now let's see how to move the player with these inputs. For that, I will write Transform.Translate of x into speed into Time.deltaTime, comma 0, comma z into speed into Time.deltaTime. Here translate simply means move the object from its current position. The x value controls left or right movement, the z value controls forward and backward movement, and speed controls how fast the player moves. You will also see Time.deltaTime here. This makes sure the player moves at the same speed on every computer. Without it, on a fast computer, your character might run like a superhero, and on a slow computer, they might be more like they just woke up from a nap. Now we need to attach the script to the player. So we go back to the Unity, select the player game object, and drag the script onto it. Now when I click on play button and clicking on keyboard, you will be able to see that player is actually moving. But there is another important component we should talk about, and that is rigid body. If the player doesn't have rigid body, Unity physics system won't affect it. That means things like gravity and realistic collisions won't work properly. So usually we add a rigid body component to the player, so Unity physics engine can do its job. But here is the interesting part. The method we use at Transform.Translate directly changes the position instead of letting physics handle the moment. Let's understand that with a real life example. Imagine this toy is our player. When I move the toy like this, I am directly changing its position. That's actually what Transform.Translate does. But if I push the toy like this, it can go straight through other objects. No collision, no resistance. The toy just says, "Excuse me, physics, I am going through." The same thing was happening in Unity because Transform.Translate ignores the physics system. And physics is extremely important in games. Physics handles collision, gravity, and interaction between objects. Without physics, player might walk through walls, which might be funny once but probably not the feature you were playing. That's why developers often use other movement methods instead of this. They are rigid body velocity, add force, move position, or character controller movement. Each of these works differently and is useful for different types of games. If you want, I can break down all these movement methods and show exactly when to use each one. Just comment down moment and stay tuned to our channel to get all these updates. And I hope you enjoyed this video, and thanks for watching.